Hello students, in this video lecture, I'm going to quickly explain how Dijkstras algorithm has to be applied to find shortest path and shortest distance between two vertices. So on the left on the screen, you can see there is a graph in which there are vertices A, B, C, D, E, F. And what we have to do is that we have to find out the shortest path and the shortest distance between vertices A and F. You can assume that these vertices A, B, C, D, E, F, they are cities. And the numbers the non-negative numbers which are put on every edge. For example, the number 6 is on the edge AB, number 2 is on the edge BC, and so on. These are weights of the edges, and these weights can be assumed to be road distances. So if A is a city and B is a city, and if we are moving from A to B, then the distance traveled according to this example can be taken as 6 units or 6 kilometers or 6 whatever are the units in this example. So in this way you can understand the weights which are associated with each edge. Now coming to, as I said already, we have to find what is the shortest distance and the shortest path traveled from vertex A to F. So for that we have to apply Dijkstras algorithm, and now step by step the steps are like this. The first step is that what you have to do is that you have to assign labels to vertices. So the first vertex which is given a label is the vertex A, because we are starting our journey from A. So A is the first vertex which is given a label. Now because we are starting our journey from A, so we have not traveled any distance so far, so the distance traveled is 0. So I write as something in brackets, I write something dash 0. 0 means that you have not traveled any distance so far, and because you have not traveled from any vertex to vertex A is the starting vertex, so I put a dash over here. This means that you have not traveled from any vertex, you have not started your journey from any other vertex and you have reached A. You are starting your journey from A itself. So A is the first vertex which is given a label, and the label which I give to A is dash 0. This is the first step, which you can see I'm putting on the label on the graph along with the vertex A. Now, the second step is that you have to find out all the labeled vertices so far. That is, all the vertices which have attained a label so far. The only vertex which has attained a label, I'm trying to find out all the labeled vertices. The only vertex which has attained a label so far is A, and the label that it has attained is dash 0. The label which it has got is dash 0. Now, corresponding to all the labeled vertices, we find all the neighboring unlabeled vertices. Neighboring unlabeled vertices means all the adjacent unlabeled vertices, all those vertices which are neighbors of A, that is, they share a common edge with A and they have not received any label. Now if you take a look at the vertex A, then A has two neighbors. A has two adjacent vertices, one is B and the other is D, and both of them don't have a label. They both of them are adjacent unlabeled vertices or neighboring unlabeled vertices. Now if you travel along the edge AB, on the left of the screen you can see, if you travel from A, if you travel along the edge AB to reach B, then the distance traveled will be the distance traveled so far, which is 0 plus 6, which is the weight of the edge. So the distance traveled will be 0 plus 6, which is 6. Now if we travel from the vertex A to the vertex D by taking this path AD, then the distance traveled will be the distance traveled so far, which is 0 plus 5. So it will be 0 plus 5, which is 5. So these are the two distances that we are getting. Out of these two distances, we find out the minimum, that is, we find out minimum of 6 and 5, which obviously occurs at 5. So this means that wherever minimum occurs, which is occurring for the vertex D, that vertex will receive a label. So D receives a label. This is one thing. And what is the label that it receives? Something dash something. Now the second component of this ordered pair is going to be the distance which we have got as the minimum, so it is 5, and from because of which vertex D has received a label. D has received a label because of the vertex A, so we write A comma 5. So the label which we give to D is A comma 5. So this completes the second step. Now coming to the next step, again we look out for all the labeled vertices so far, all the labeled which have got a label so far, and they are A. One is A and the other is D, and the label which A has got is dash 0 and the label which D has got is A comma 5. Now, corresponding to this labeled vertex A, find out all the neighboring vertices which have not received a label. That is, find out all the adjacent unlabeled vertices. Now, there are two vertices which are adjacent to A, or two vertices which are neighbors of A. One is D, but that is already labeled, so we will not take D into consideration. The only remaining vertex which is adjacent to A, or which is a neighbor of A and which has not received a label, is B. So now if we travel from A to B along the edge AB, then the distance traveled will be the distance traveled so far, which is 0, 0 plus the weight of the edge AB, which is 0 plus 6, which is 6. So here we make this calculation. Now again, for the labeled vertex D, we find out all the neighbors of D, all the neighboring vertices of D which have not received a label. That is, we find out all the adjacent unlabeled vertices of D. Now D has got neighbor. One neighbor of D is A. We can see that D and A are adjacent because there is a common edge between D and A, but A has already received a label. Then the other neighboring vertex of D, or other adjacent vertex of D which has not received a label, is C. And if we travel from D to C, then the distance traveled will be the distance traveled so far, which is 5 plus 7. 5 plus 7, which is 12. This is for the vertex C. Then the other neighboring vertex of D, or the adjacent vertex of D, which has not received a label so far, is E. And if we travel from D to E along the edge DE, then the distance traveled till E will be 5. The distance traveled so far plus 8, which is 13. So there is no other adjacent vertex to D which has not received a label. So these are the only, finally, these are the three unlabeled vertices which we have got, B, C, and E, and the numbers are 6, 12, and 13, and we have to find out the minimum of 6, 12, and 13, and obviously the minimum occurs at 6, which means the minimum is occurring at 6. So B is the next vertex which receives the label. Wherever the minimum occurs, that is the vertex which receives the label. So B receives the label, which is a form of an ordered pair, something, comma, something. And the second part of this ordered pair is going to be this minimum, which is 6. And because of which vertex is B receiving a label? B has received a label because of A. So A, comma, 6. A, comma 6. A, comma 6 is the label of B. So again, so this step is complete now. Now coming to the next step, again find out all the vertices which have been labeled so far. So all the vertices which have been labeled so far are, one of them is A, and the label that it has received is -0. And now find out all the neighboring vertices of A, or all the adjacent vertices of A which have not received a label, which are unlabeled. A has got two neighbors, B and D. We can see there are two neighbors, there are two adjacent vertices of A, B and D, but B has already received a label, D has also received a label, which means that A will not participate in this step because A has not got any adjacent unlabeled vertices, or A has not got any neighboring unlabeled vertices, or neighboring vertices which have not received a label. Then coming to the other labeled vertex, the other labeled vertex is B, and the label which B has just received is A, comma 6. And let us find out all the neighboring vertices of B which have not received a label. Now one neighbor of B is A, but A has already received a label. The other neighbor of B is C, and C has not received a label. So if you travel from B to C along the edge BC, then the distance traveled will be the distance traveled so far, which is 6 plus 2. So this will be 6 plus 2, which is 8. This is for C. Next labeled vertex is also another labeled vertex, and the label which D has is A, comma 5. And what are the neighboring vertices of D, or adjacent vertices of D, which don't have a label? Now one neighbor of D is A, but A already has a label. The other neighbor of D is C, and C doesn't have a label. So if you travel from D to C along the edge DC, then the distance traveled will be the distance traveled so far, which is 5 plus 7. So this will be 5 plus 7, which is 12. And the other neighbor of D, or other adjacent vertex of D, is E, and E also has not received any label. And if you travel from D to E, then the distance traveled will, from D to E, will be the distance traveled. So the total distance traveled till E will be the distance traveled so far, which is 5 plus the distance, the weight of the edge DE, which is 8, which is 13. So there are three numbers that we have got, 8, 12, and 13, and we have to find out their minimum. So the minimum of 8, 12, and 13 obviously comes out to be 8. So this means that the minimum is occurring at 8. So C is the next vertex which receives a label, and the label will be of this form: something, comma, something, and this something, the second component of this ordered pair is going to be 8, and this label which C is receiving is because of B, so we write B over here. So this step is complete. Now coming to the next step. This step was step 4. Now coming to step 5. Now again take all the labeled vertices and corresponding to those labeled vertices, find the adjacent unlabeled vertices. Now A is a vertex which has received a label which is -0, but A has neighbors two. There are two neighbors which A has, B and D, but both have received a label, so A will not participate in this step. Then coming to B, B also is another labeled vertex, and the label which B has received is A, 6, and B has two neighbors, A and C, but both A and C have received a label, so B will also not participate in this step. Then coming to D, D has received a label which is A, 5, and now finding out all those neighbors of D, all those adjacent vertices of D which have not received a label. Now D has one neighbor which is A, but A has received a label. D has another neighbor or another adjacent vertex which is C, but C also has received a label. And D has the third neighbor which is adjacent vertex which is E, and E is still unlabeled. It has not received a label. And if you travel from D to E, if you take this edge, then the distance traveled till E will be the distance traveled so far, which means 5 plus 8, which will be 13. So this is what we have. And then coming to C, which has again received a label which is B8, and finding out all the neighboring vertices of C which have not received a label. There are so many vertices of C which are neighbors. C has neighbor B, but B has already received a label. C has neighbor D, but D has received a label. C has neighbor E, and E has not received a label. So if you travel from C to E, the distance traveled till E will be the distance traveled so far, which is 8 plus 9. This will be 8 plus 9, which is 17. Then again, C has another neighboring vertex or another adjacent vertex which has not received a label, which is F. So if you travel from C to F using this edge CF, then the distance traveled will be the distance traveled till F will be the distance traveled so far will be which is 8 plus 5, 8 plus 5, which is 13. So there are three numbers that we have, 13, 17, and 13, of which we have to find out the minimum. And obviously the minimum is 13, but 13 is coming at two places. So we can choose either this 13 or we can choose this 13. We have to go on continuing with Dijkstras algorithm till all the vertices have attained a label, till all the vertices have got a label. So we can take any one of them. Either you can take the minimum at E, or you can take the minimum at F. Let me take the minimum at E. So I'm taking this minimum. So the minimum occurs at E. This means E is the next vertex which receives a label, and the label will be of the form of ordered pair, something, comma, something, and that second component of this label is going to be 13. This number, which is the minimum, and because E is getting a label because of vertex D, so this D comes over here. And now coming to the next step, which is the sixth step. Now again find out all the vertices which have been labeled so far. A has received a label -0, but we have seen that it doesn't have any neighbors. It doesn't have any neighboring vertices which are unlabeled. The two neighbors of A, which are B and D, they already have a label, so A will not be participating in this step. Then B has received label A6, and the neighbors of B are A and C, which have already received a label, so this will also not be participating. Then D has got label A5, and the neighbors of D are A, which has received a label, C, which has received a label, E, which has received a label. So again, D will also not be participating. Then coming to C, C has got label B8, and the neighbors of C the neighbors of C which have not received a label. C has got many neighbors. C has got neighbor B, but it has a label. C has got label D, but it has a label. C has got neighbor E, but it has a label. C has got neighbor F, and F has not received any label. So if you travel from C to F, then the distance traveled till F will be the distance traveled so far, which is 8 plus 5, 8 plus 5, which is 13. Then again, we have seen C, and now let me check E. E is a vertex which has been given label D, 13. And if you take a look at the neighboring unlabeled vertices of the vertices for E, E has neighbor D, but D has received a label. E has neighbor C, C has received a label, and E has neighbor F, which has not received a label. And if you travel from E to F, then the distance traveled till F is going to be the distance traveled so far, which is 13 plus 4, which is 17. And we have to find out the minimum of these two numbers. The minimum, of course, is 13. So this means F is the vertex which attains a label, and the label will be something comma something, and this second component of this ordered pair is 13. And because of C, this label is being attained, so it will be C. It will be C comma 13. So all the vertices we can see have attained a label. And now let me find out what is the shortest distance between the vertex A and the vertex F, and what is the shortest path for traveling from vertex A to vertex F. Now, if you see the label of F, the label of F is C13. So 13 is the shortest distance. This 13, this is the shortest distance between A and F. And what is the shortest path? The label of F. In the label of F, you have C. In the label of C, you have B. And in the label of B, you have A. So A, B, C, F, this is the shortest path. And if we just have a look, then AB, if we want to verify again, the weight of AB, is 6. The weight of BC is 2. And the weight of CF, is 5, which means 6 plus 2 is 8. 8 plus 5 is 13. So 13 is the distance traveled along this path. So this is how the Dijkstras algorithm has to be applied to find out the shortest distance between two vertices and the shortest path between two vertices, which in this case are vertices A and F.